Hey everybody, welcome back once again. In this video, we're going to take a look at a simulation, just kind of another example of the central limit theorem and what we are doing when we're talking about sampling distributions and the idea right behind the central limit theorem. So the idea with this sampling distribution, right, is that you start with any population. It could be a normal distribution or it could be non-normal. For this illustration, let's start with a skewed population distribution, right? This could be just about any population we could think of. You can see we're given here the mean, median, standard deviation of our skewed distribution. And so if we take a sample from this skewed distribution over and over again of size 5, right? So we are going to take 5 randomly selected data points from this population, and then we're going to take their mean, right? And that is going to get plotted down here. So the 5 that we sample from will be shown here briefly, and then that average will get plotted right here. So let's click this button and we'll see that happen. So here's the 5 random samples, right? Looks like we got maybe a 0 to 5, 8, and maybe a 13. So we added those together, divided by 5, right, as the sample size. And we got one average, right, or one sample mean. So I could do this again. And we'd get another sample mean, right? It's a little bit less. So you can see how many times we've done this, what the mean is. Apparently it's 0. Don't know how that works. And our median, right? But I could click this button, right? And it just did that 5 times, right? So now we're up to 7. We got 5 more sample means, and the mean of that sample mean is 5.47, the median is 6, and the standard deviation is 4.54. So remember, as we do this more and more, we expect this mean to be the same mean that we started with, right, from our actual population. And we expect our standard deviation, right, to be smaller. We expect it to be our population standard deviation divided by the square root of our sample size. So now let's do this instead of 5 times, let's do this 10,000 times and get 10,000 sample means down here. So we've done this 10,000 times, and you can see how normally distributed it looks, right? It's not perfect, but it's pretty darn close to normal. And we can see that the mean of our sampling distributions, right? These are all sample means that came from our parent population. Our starting population, these are all sample means that we've plotted, right? The mean of those sample means is already very close to that 8.08. And we can see the standard deviation is much smaller, right, than our parent population, which makes sense because, again, we expect it to be our population standard deviation divided by the square root of n. So if we do this another 10,000 times, you can see it's 8.09, right? And it kind of stays very consistent even if we do it 100,000 more times. So again, this is the idea with the central limit theorem, right? You can start from any kind of distribution. It doesn't have to be normal. And then if you take samples from that population, you take the mean of those samples and you do that many, many times, the more times you do it, the closer and closer you'll get to a normal distribution for that sample statistic, right? In this case, it's the sample mean. So this is the sampling distribution of the sample mean. And so this is what's happening when we're working on these problems and using the central limit theorem.